All right, gentlemen. So we get started in like 10 minutes. So I'm just gonna do some streaming. I think I should be able to squeeze a brawl in there. If I don't finish, then I'm gonna just have to take that L. But I'm gonna just start a quick match. Come on. Hopefully it works. The brawl. Go. If you have questions, this is a good time. I'm gonna ask them. Ooh, oh, that's my favorite character. They got my Diggy. Switch this one. Oh, but I gotta go Nana. Diggy and Nana. Oh, my lantern. No, and again. This should be good. Like,
if I was just a tree in the forest, would things have been different?
Pro setup. Let's use that one. No, not that one. We'll use this. We'll replace this. That's fine. And what I'll do, I'm gonna do something. So somebody can do some help. Let's rock and roll. Now buy some mana boots off the rip. Top is it? I got exactly 10 minutos más. Oh, yes. That reminds me, a friend of mine just sent me a message. Did you all enjoy the eclipse today? All right? Did you get out there and experience it at all? I got some footage. Happened to, we had some of those glasses so that you can see it. Because at first, nobody had any, and then one person in the group had some glasses. So we had like a little session. Each person got to view it periodically and just view pass. So it was really interesting. And so basically, what I did, I held the glasses. Because when you look through the glasses, it's pitch black. You can't see anything. Then when you look up at the sun, all you can see is the sun. So I held the glasses up to my lens. First, this one, Rome. I am going to buy this for a little bit of extra money. We can let the rest of it rock and roll. All right. Oh, so they already got killed. Let me get up in there. I'm late to the party, but that's okay. Oh, he's about to die. Where is he? I got him. Get him, Diggy. Woo! Got him, coach. This is a nasty combo. Ooh, he got me. Spike. Thank you, Diggy. Oh, he teleported.
You will be punished if done wrong. An enemy has been slain.
And flicker.
None is on her way.
He's talking about being invisible.
enemy.
3, 2. Especially someone who gets caught in something.
It's no, don't bully me.
An enemy has been slain. Killing spree.
Hi-ya.
Let's go. Y'all don't need to heal? Nobody needs to heal? Okay.
Don't look down on me, Nana.
Initiate retreat. An enemy has been slain. Ally has been slain.
Like, man, you just sticking.
The sunshine is so warm. You will be punished.
Ally has been slain.
Hey, we all got on that one. Woo. All right, I got it back up. 5 seconds. I don't know that we're going to win because I don't know that we have marksmen. They got a couple of marksmen. So as they get stronger, it's going to be harder and harder to kill them.
An enemy has been slain.
Don't bully me.
An enemy has been slain.
Oh, my team came back with a vengeance. I'm going to get this. Some healing. Yes. So get up, everybody. Yes.
Double kill.
Stay happy, everybody.
Your team destroyed the turret. An enemy has been slain.
You will be punished if you've done something wrong. Hi-ya.
Hey, there's a flame shot. We need a flame shot.
Nana's getting
Ooh,
serious.
not messing around. He's like, I'm coming for you.
Slain. Double kill. Enemy has been slain. Ally has been slain. Ally has been slain.
Go ahead, get to that.
Spree.
That's why I chose the things that I chose. Got on purpose. Ooh, I gotta back up. Shit, don't hurt me down.
Want to see some magic?
Yeah, not messing around.
An enemy has been slain. Double kill.
You will be punished if you've done
Mega kill.
5 minutes. Oh,
it.
I know it's people in the waiting room. You for the third.
Good.
Right.
Hi-ya.
That's how they be catching us getting deep into our backfield.
Don't bully me.
Woo. And to the wire.
Hi-ya. You are lucky to have Nana by your side.
I'm coming back with a vengeance. Let me meet some people in there. Who's in the
Mega kill.
um, 4. Rock and roll.
Time to play.
What's his name? Kept ganking me, but that's okay. We're gonna get him. Dumb stuff. Get him, Diggy.
Never too late to be happy. Hi-ya.
as fast as you can. Got him! With 2 minutes left on the. It took it like right at just under 8 minutes. And Diggy, I'm telling you, Diggy and Nana, oh, that's a disgusting combo. I hate having to win against them. Because Diggy frees his teammates, so all that little CC. Only reason they got me is because he got the teleport. Oh, come on, I did better than Silver. That was definitely better than the Silver performance. But it's all right. It's fun. What time is it? I got right here 2 minutes left. Man, I just knew I only died once, so she only died once. I guess she was getting closer than me. I was getting in there. All right, gentlemen. Let's see. So we still got a solid minute. Just trying to let the time mature. All right, let it get to 6 p.m. and we'll get started. Let me see. So yeah, let me look at watch the clock. So yeah, while we kind of wait for class to start, hopefully you all able. One, let me make sure. I guess you guys can hear me. You should be able to. Yeah. Hopefully you all were able to get out and like experience the eclipse. You know what I mean? Yeah. Like fortunately, one person in our group had some glasses, so we all were able to witness it. At one point, I panicked though because I looked up and then I started getting dizzy and I started seeing stars. I was like, "Oh no, I'm about to lose. I'm about to go blind." I was like, "I'm coming home." Right? I started panicking. No, I'm just out of shape. I just stood up too fast and like got dizzy. I was like, "Oh crap, okay." But yeah, it was kind of trippy. Like, and I confirmed some things that I had seen in videos where. In videos that I had seen in the past, people were like, in an eclipse, the shadows start to like eclipse as well. They start to take on this weird shape. And sure enough, you know, on the ground, I was able to get some footage of like the shadows becoming like a crescent moon or cyclical, like a sickle shape. So, you know, that was interesting. We weren't in the, here. We weren't in the. We didn't get 100% totality. Like we didn't get 100%. We got up to like maybe 85 or 90% totality. Like it was pretty close. It was just fun, and it didn't get all the way dark. It just like it's like somebody had like dimmed the lights a little bit. Like now it looks normal, like extra bright. You know. Some other strange things. I see that it's time. Some other strange things. Like one, supposedly NASA launched rockets into it, and I couldn't see that from where I was at. Let me check and see if we got anybody else in the waiting room. Cool. Okay. But yeah, that's supposedly one thing that was going on. Another set of events that supposedly was going on was that I don't know if you heard of like CERN. I guess in like Switzerland. Supposedly they activated their device today during the eclipse, and there's supposed to be another like mini hadron collider in like Chicago. So these two, particle colliders supposedly were activated. One video I saw with the activation of the hadron collider in Chicago, there was like a huge like lightning storm activity when they turned it on, above it. So, and one group was like, they were listening to, I guess it was NASA or some official, and they said ellipse instead of saying eclipse. And so then the groups like launched into this thing about, ellipse power or whatever. And so I guess like if you have like kidney stones, there's a device that's based on ellipses where you have like one point of high energy and it uses the curved dome to focus energy at another focal point. So they were trying to allude to something of that nature. But I mean, we're all here, right? It's like come and gone. So it's just fun. Another friend of mine was like, "Oh, we finally get that powers." She was like, she messaged me today. What was she talking about? She was like, I keep practicing. I'll do my, tingling, try to see electricity's coming over fingers. I was like, nah, nothing happened. And when I woke up this morning, I stretched. I was like, did it move? No. That was just me stretching. It was false alarm. So no powers. But then I asked her, I was like, well, if you could choose your powers, like what powers would you have? This is just fun stuff, right? I think she said teleportation. And my response was like, teleportation kind of wigs me out a little bit because, you know, a lot of the teleporting heroes or whatever, they'll be like, well, I have to have seen the place before I go, because if I try to teleport someplace I've never seen, I could end up in a wall. And I was like, yeah, that makes a lot of sense. If you just try to like jump someplace and you don't have a sense of the terrain, you can end up underground or in the wall, stuck somewhere, right? Maybe you could teleport out. I don't know, but I wouldn't want to find out. I told her that if I had the choice of the power, I would choose this power. Once upon a time, there was this series called Heroes, right? That was one of my favorite series. Oh my God, that series was so good. And it was based on eclipses. They got their powers from eclipses. I don't know if that's a plural of eclipse or not, but yeah. And so in that show, one of the protagonists, his name is Peter Petrelli, and he could like basically absorb people's powers. I guess it was just by the thought of them. I'm not sure exactly how it would work, but he can absorb people's powers. Like when he discovers a power of somebody, he would take it on. I don't know if it was based on proximity or just based on the thought. But if I had a power, I would be able to absorb people's powers just by thinking, just by thought alone. So I mean, that was an interesting series, but I think it ran for about 4 seasons and it had to be cut short because of plagiarism. Right? It surfaced that they were basically grifting, I guess, from like a comic or something. So they had to shut it down. But the storyline was good. It was captivating and intriguing. Like, you know, it was fun. So anyway, that's just a little bit of highlight of today with the eclipse and all that stuff. Hopefully, again, let me check one more time to see if we got any strike. Oh, more people. Okay. I should have turned the other thing on, but that's okay. We're here now. Let's get this. This more. Anyway, yeah. So now let's get to the nitty gritty and the meat and potatoes. Let's see. So I want to say I updated you all's grades. So I know I made an announcement about that. So kind of check the announcement. As of late, instead of like typing stuff up, I just been doing like audio messages. So, you know, you should be able to access that and get those details. We are in the home stretch, gentlemen. This week is going to be the last of the new material. Today, we're going to be working on section 4.5, integration techniques. I think it's substitution. And then Wednesday is the last of the new material. We're going to be working on section 4.6, integration techniques, integration by parts. All right. So after that, then I think we have exam 2, and we can take the week to review, right? You know, we'll kind of play it by ear. Yeah, we'll play it by ear. But yeah, we're in the home stretch, right? So this is the last of the new material. We have this week, and then next week I think is exam 2 over chapters 3 and 4. And then shortly thereafter, we're going to be reviewing for the final. More than likely, I think our rhythm will have about like a chapter a day. I had to kind of check the schedule. And then our final exam will become available pretty much. I think I scheduled it to become available for the entire week of finals. So from that Monday to Friday, that Friday is that Friday the 13th? Is that Friday the May 13th? Let me see. April. That's the 3rd. Oh, it's the 10th. Okay, so that's a Monday the 13th. Okay. So I think Friday. Yes.
When is going to be the last day for turning in late assignment?
That Friday. So that Friday, May 10th that's a great question. That Friday, May 10th is the hard deadline for all assignments, right? So for all our assignments, we have those soft due dates. If we submit them past those due dates, there's a 5% late penalty. But the hard deadline for all assignments is that Friday, May 10th at 11:59 p.m. because shortly thereafter, we have to calculate final grades and submit them for processing.
Okay, thank you.
That's a great question. So we have the 2 exams. Trying to think if there's anything else. Okay, I can't think of anything else. So yeah, this is the last of the new material. Exam 2 should become available this Sunday. Is due the following Sunday. And between reviewing for exam 2 and reviewing for the final, that's pretty much what we'll be doing starting next week on to the end. Okay. And you guys have the idea as usual. If you have any questions, feel free to unmute yourself to get my attention and we can talk about it. And we did a little Easter egg today, like before the start of class. I just did some streaming and it was pretty smooth. It was okay. I was surprised. I did a little bit of streaming of my gaming. And so you may witness like, it's not a direct application of calculus, but I am using a lot of timing, baiting, psychology, frequency and rhythm, geometry, courage, team morale, cooperation, planning. It's a lot of chest energy. But the one I did today is like, it's called a brawl, and it's just like one lane, and it's like 5-on-5. We just go head to head, right? So I had a lot of fun. We won. I didn't do as well as I thought I was doing, but we won, and that's usually my objective is to win. So I was happy about that. And there was no lag. Usually when I stream, the lag can like make or break the whole experience. So that game is called Mobile Legends, or Bang Bang Mobile Legends, right? Okay. So let's see. All right. So let me see. So we've been working calculus and its applications and calculus and its what? That's a weird title. Anyway, chapter 4, integration. And again, today we're going to be working on section 4.5, integration techniques, substitution. Now, I really like these two topics. These are just some techniques for taking the integral. We've explored some, like how to, we've explored some integration techniques. So here's some alternate ones. And so again, today we're going to be working on this one called substitution. So a few objectives here. 1, evaluate integrals using substitution. 2, solve applied problems involving integration by substitution. Okay. All right, let's see. So the following formulas provide a basis for an integration technique called substitution. So we have the integral of u to the power of r, where u is like some function. Then that's kind of like what we've been experienced, right? That integral is going to be u to the power of r plus 1 over r plus 1 plus some constant of integration. The integral of e to the power of u, again, u is just some expression, du, is going to be e to the u plus c. Let me see. Okay, that's when we have e to the u times du, okay? If we have du over u, that integral is going to be the natural log of absolute value of u plus c, or the natural log of u plus c whenever u is positive. Unless noted otherwise, we will assume that u is positive. Okay, let's see what else. Okay, so for this function, find dy. Okay, I get it. Okay, that's it. Let me grab this. What did I do with that? Did I do it in wash? Where is it? Work to do. Use this one. Use this one now. Sorry. All right, I'm back. All right, so given this function, find dy, right? So in other words, they're asking us to find the derivative with respect to y, or just dy, right? So let's see, we're going to start with, we have y equals x cubed. So then if we take the derivative on both sides, the derivative on the left is going to give us dy. The derivative of x cubed is going to be 3x squared dx. So then dy should be 3x squared dx. So whenever we take the derivative of, like, this is called implicit differentiation. Whenever we take the derivative of a variable, we put either dy or dx, right? Depending on whatever we're taking the derivative of. This one should be 3x squared dx. Come on. Okay. All right, let's see the next one. For this function, find du. Okay. So we have u equals x to the power of 2 over 3. So then du is going to be, if we take the derivative on the right, the 2/3 comes down. We're going to have x, we subtract 1, so there's going to be a negative 1/3 dx. Right? So you could look at this as 2 dx over 3 times the cube root of x. I'm going to leave it like this for now. Okay. Yeah, this is good. Let me check one more time. I'll let him in. Let's see. Oh, he was here. Okay, that's fine. I think that's right. Okay, let's keep going. For y equals this, find dy. Okay, so if our y equals e to the power of x squared, so then our dy is going to be the derivative of e is itself times the derivative of that power, which is going to be 2x dx. We could write this as dy. I mean, what we have is fine. We could also do 2x e to the x squared dx. Okay, so far we've really just been taking the derivative, and instead of writing dy by dx, we've been moving the dx to the right-hand side of the equal sign. That's all we're really doing. So all of this is a review so far. I'll leave that as an exercise. And we're essentially already halfway through this section. Evaluate this. Okay, so now, this section is substitution. So let's see if we can do substitution. So if we are going to do substitution, if we're going to do it right, the trick is choosing the correct value of u. So we're going to say, let's try let u equal, let's try x cubed plus 1, right? If that's our u, then our du is going to be 3x squared dx, right? I think that's good, right? So now, again, if we're starting with the integral 3x squared times x cubed plus 1 to the power of 10 dx, if we're starting there, we do our u substitution. So then we're going to have the integral. Looks like we have u. Here, let's do this. Du, let's do that one in this color. So u is right here. Our du is here. Right. So notice we have what? U to the power of 10 times du. Right? U to the power of 10 du. Right? Okay. So then now we can integrate u to the power of 10. That's something that we're familiar with. If we integrate, we're going to get what? U to the power of 11 over 11. So u to the power of 11 over 11 plus some constant of integration. So then we back substitute. So but u is x cubed plus 1. So ultimately we get x cubed Sorry about that. I look like I got booted off screen. Start the broadcast. Okay, we should be back. Yeah. So, anywho, so if we have u to the -1, we can apply the power rule. So we should be able to add 1, right? So this should be negative u to the -1 plus some constant of integration. Because if you check by taking the derivative, right, the power comes down, you subtract 1, we get our desired result, right? So then we got a back substitute. So then our u, so ultimately it looks like we have a negative. Now on bottom, we have this 1. What's going on? Get rid of that. Can I go like this? That doesn't really help, but that's okay. On bottom, 1 plus x squared. Let me see if I can adjust this thing. Settings. I don't need this one. Where is my laser? I do need my laser. A laser about like there. I don't really need this one. Okay, we'll go with that. Let's see. So for u, we got 1 plus x squared. Mm-hmm. 1 plus some constant of integration. Let's see. U to the -1, so that comes down, it becomes -2 times 2x dx. Yeah, I think we're good. Negative 1 over 1 plus x squared plus c. Okay, so quick check, I leave. As an exercise, let's look at this example 7, evaluate, okay? So, again, in the spirit of u substitution, let's let u be, let's try 3x. If that's our u, then our du, it will be what? Let's see. If our u, then our du would be what? 3 dx, and that. I think we need a different u and du. So I don't think this one is working. So let me scratch this and try a different one. Okay. What if we let our u be the natural log of 3x? And that means our du will be, what's the derivative of that? Du over u, so that's going to be 3 over 3x dx, which is ultimately dx over x, right? That's exactly what we want, dx over x. Okay, so let's do these substitutions. I'm going to kind of work over here. Okay. So let me see. It looks like we're working with the integral of u is that. It looks like it's u du. U du, right? Because u is natural log of 3x, du is dx over x. So then we're working with u du, right? So then the integral of u is going to be what? U squared over 2 plus some constant of integration. And then we reverse substitute or back substitute. So it's going to be the natural log of 3x quantity squared plus some constant of integration. Let's see. Let's do a quick check. If we were to take the derivative, the 2 will come down, right? We would still have natural log of 3x. Then we have to say times the derivative of the inside. So that would be 3x over x. Oh, okay, wait a minute. Oh, I see what we're forgetting. I was like, something's a little off right here. U squared over 2, so we need the 2 right here. There we go. Okay, so now when we take the derivative, 2 comes down, they'll cancel. Times the derivative of the inside function, so that's going to be du over u, so that's going to be 3 over 3x. I think this is okay. The constant is gone. Natural log of 3x squared over 2. Okay. Okay, so with this one, let's let u be, let's try x squared. If that's our u, then our du would be 2x dx. Okay, I think this is okay, right? Now let's do the following. But notice that we don't have 2x dx, we have x dx. So we want that du to match what's given originally. So what we're going to do is divide both sides by 2, right? So we could say half, or we could say du over 2 equals x dx. Right now we have the proper form of x dx. So now when we go to do our substitution, let's see, we're going to have our e, let me clean it up, e to the power of u, and the x dx is equal to du over 2. So it looks like we need to do du, but like this needs to be over 2. All right, we did du over 2. Okay. So then honestly, the 1/2 can just move in front of the integral, right? So this is actually the same as 1/2 times the integral of e to the u du, like that. Then we know how to integrate this guy. So I'm just going to keep working over here. This is going to be 1/2. That should be e to the u plus some constant of integration. The derivative of e is itself times du, right? I think we're good. And then we need to back substitute, right? So our u is x squared, so then we get 1/2, or let's write it as e to the x squared over 2 plus some constant of integration. Okay. And again, we would check by taking the derivative. If we take the derivative, we should get back to where we started. We got e to the x squared over 2 plus some constant of integration. E to the x squared over 2 plus some integration. Yeah. We're actually almost done with this section. We got 8 more slides. 7, 6. Okay. All right, let's try u substitution. So, I mean, all of these are substitutions. So let's let u equal, let's try x plus 3. If that's our u, then our du would be just dx, all right? So I think that's, okay, that's fine. So then we have this x plus 3 under dx. We're taking the integral. And we do our u substitution. So it looks like we have du over u. And the integral of that guy is going to be natural log of u plus some constant of integration. So then ultimately, it should be the natural log of x plus 3 plus some constant of integration. Should be okay. Okay. Natural log of x plus 3 plus some constant of integration. So that derivative would just be dx over. Yeah, I think we're okay. Okay, let's see what else we got. We got about 5 slides left. Okay, evaluates. Okay, we're going to do U substitution. So then, let's see. Let's let U equal. Let's try x squared plus 3. Okay. So that means our du would be what? 2x dx. Okay. We got the x dx. Now that 5, we can just move in front of the integral. So we can essentially ignore it. We can just move the 5 in front of the integral and proceed. Now, notice they don't have the 2. They do have the x dx. So we need to move that 2. We need to divide both sides by 2. Right? So then 1/2 of du equals x dx. Okay? So remember, the 5 can move in front, and ultimately we're going to move that half in front as well, right? Let's try to calculate this. So if we do our U substitution, we're going to take the integral. Let me see. When x is 1, is that a 4? Because see, that's the integral as x goes from 0 to 1. If we're doing it in terms of U, I think what we need to do is let x be 1, right? Because that's our upper limit. We get a result of 4. And when x is 0, we get 3. So I think we need to make that adjustment when we do our U substitution. We're just going to work with this for now. We might not, we're probably going to put it back, but I'm just going to move forward like this for now. So now we have what? The square root of U. Let me see. The square root of U. We got the x dx. We said we moved the 5 in front of the integral. And so we need a half du. Keep in mind this du is outside the radical, so there's a du there. And I'm going to move the half outside as well. Okay. So instead of writing half of du, I move that half outside the integral. Okay, that's just a property of integrals that we can do, right? Whenever we multiply by a constant, we can move that constant to the left side of the integral sign symbol. Okay, so then the integral of this guy, so the 5/2 is going to persist. Let me see. 1/2, so that's going to become what? U to the power of 3/2 over 3/2. We want to evaluate this as U goes from 3 to 4. But I think we can back substitute at this point now, right? We might be able to do the 4 and the 3, but I feel inclined to back substitute. Let me see. If we're dividing by 3/2, that's the same as multiplying by 2/3, right? So 2 over 3. So then it should become 5 over 3. If I back substitute, my U is x squared plus 3 to the power of 3/2. And instead of continuing from 3 to 4, right? We could probably plug in the 3 and the 4 and it should work. I mean, we can check it momentarily. I'm just going to put my original limits of integration back, right? And so this is this x goes from 0 to 1. Okay. So then when x is a 1, we get 4. Square root of 4 is 2. Cubed is 8. So it looks like we get 40 over 3 when we let x be 1. Right? If you plug in 1, 1 squared is 1, plus 3 is 4. We can do the square root of 4 is 2. 2 cubed is 8. And then 8 times 5/3 is 40/3. Okay. And then when x is 0, that's going to be more nasty because square root of 3 we can't do. We can do cubed. Let me think. So I think it's like 3 square root of 3. Okay. So it looks like we get a 3 times the square root of 3, and it's going to cancel. So we're going to get 5 times the square root of 3. I think this is the exact result, and then we would use the calculator to get an approximation. Let me try real quick. Let's see, my calculator. Reload and refresh. Okay. So let's see what number this gives us. 40 over 3 minus 5 times the square root of 3. Okay, we get something like this. And I want to kind of check some things real quick. We got 4.6731. Okay. So I kind of want to see if we did the limit of integration with that u was 4, as u goes from 3 to 4. I want to see if we get the same result, right? So what I'm going to do, I'm going to say my 5 halves, right, times, when I plug in 4, so I'm going to say 4 to the power of 3 halves, okay, divided by 3 halves, okay. Then I'm going to say minus 3 to the power of 3 halves, divided by 3 halves, okay. Then I want to close off that difference. Do we get the same decimal? We do. That was correct. Right? So because we adjusted the limits of integration up here, right? We could have crunched it there. Let u be 4, let u be 3. We got the same result. All right? So that was actually good. Okay? I mean, provided, we're not making some critical error somewhere. But we did get the same result for either of those. All right? Okay. So first we find the indefinite integral. They got the 5 halves. Okay, let me see something. If u is x squared plus 3, du is 2x dx, okay. Where? I think they're just introducing some things. But I think, let me see, 5 halves x squared plus 3. Let me see. 4.673. Yeah, see, they integrated as x went from 0 to 1. That's fine. All right, that's what we did. And I think that's what we got, 4.673. Okay. Okay. That was interesting. Okay. All right. So let me see. We got a solid like 35 minutes. We won't use all of that time, but what I can do, let me change my view. Seamless. Okay. And I'd like to hop over here. Actually, let's put this right here. That's fine for now. We're going to go to my math lab. Let's allow, sign in, allow. Calculus for business. Okay. And this is what, 4.5? Sorry. Integrate substitution, okay? And then what is it? 1 through 27. Give me a random number between 1 and 27. All right, let's start with question 2. Or come on device. Just trying to get my device to respond. There we go. Okay, we did all that right here. Can I just, there we go. Okay, darn it. Okay, let's just add a page. I think we're ready to rock and roll. Okay, so this question number 2 says, use the two given functions to write y as a function of x. Oh, so basically what we do is replace m. I think I might actually take my notes here in the text. If I need to write it out, just let me know and I'll know. But I think I'm gonna just type it here. Can I zoom in some? A little bit more. Let's see. So for instance, settings, turn this off. Okay. So we have y in terms of m and m in terms of x. So if we want y in terms of x, we just replace m with that function, right? So we're gonna have 5m minus 5. But then what is m? M is x plus 5 over 5. Okay. So then we can simplify. It looks like those 5s cancel. Looks like we just get x. Section is from augmented review. This is really old. So it's like we get just x. Let's just do another random question. Generate. Let's go to question 22. That is random. 2. So this is 27. 6, 5, 4, 3, 2. Okay. So this comes from section 4.5, question 50. Evaluate. So let's take some notes on this guy. Okay. So we're just evaluating the integral. This is question. This is question 22. Oh, not 20. This is question 22. This comes from section 4.5, question 50. We're asked to evaluate. We got the integral as t goes from -4 to 1. On the bottom, we have 5 plus t. On top, we have dt. Okay. So if we're trying our substitution technique, we might say something like, let u be, let's try 5 plus t. So then our du would be dt. Okay. I'll keep working over here. So it looks like we have du over u, right? Let me see. This would be the integral as what u goes from 6 is on top. And looks like a 1 is on bottom. Okay. Looks like it's a du over u. So that integral looks like it's natural log of u. As u goes from 1 to 6. Now we should be able to evaluate it here and get the result. I'll leave some space, but if we back substitute Are you, so we would have the natural log of 5 plus t as t goes from -4 to 1, right? As long as you back substitute, you don't have to adjust those limits of integration. So it should just be the natural log of 6. We're getting natural log of 6 there. Here is what? The natural log of 6. Natural log of 1 is 0. So in either case, we got the natural log of 6. Okay. Okay. An exact answer. So I think I just want the natural log of 6. It's the time. We'll probably hang out for right at about 10 more minutes. So I can give myself a little bit of space between courses. I probably will skip number 1. I mean, maybe, let's see how quick. Maybe it's quick. Use the 2 given functions to write y as a function of x. So kind of a repeat, all right? So y is going to be what, 5a? We don't need the a, but 5a plus 3. But what's a? A is -5x minus 3. Then if we distribute -25x minus 15 plus 3, let's take as a -25x minus 12. Okay. Let's go to question 23. It's kind of going early, late, early, late. So if that's 22, this should be 23. All right, so this looks like you substitution. I'm going to, come on. Right there. So this is question 3. I think I need to zoom out just a little bit. So this is question 23. This comes to section 4.5, question 52. Let's see. So it asks us to evaluate. We got the integral as x goes from 2 to 6. On the bottom, we have x squared plus x minus 5. On top, we have 2x plus 1 dx. Okay. So we might, let me see, let u equal probably the denominator x squared plus x minus 5. So that means our du would be what? 2x plus 1. Okay, that's dx, right? Okay. So then if we do our u substitution, let me see. That's 30, so that's a 25 there. 4, 6, 1. Are we doing du? Is it du over u? It's looking like du over u. So that's going to be the natural log of u as u goes from 1 to 25. Okay. So then natural log of 1 is 0. And we just, natural log of 25, I mean, that's 2 times the natural log of 5, but we can just leave it as it should just be the natural log of 25. Okay. Natural log of 25. LN25. Let's see. Power rule. That's 5 squared. We could do 2x. It might be the way we have it written. We might need to write it as 2 times the natural log of 5. What I'm going to do is view an example. Oh, they don't have an example. Let me expand this. Okay. We could try 2 times the natural log of 5. To use that. Let me check this again. So if we plug in 6 into U, 30, oh, I definitely subtracted. Okay. So 36 plus 6 is 42, 37. So I think instead of that being 25, that's supposed to be a 37. I think I just did my upper limit wrong. I think it's 37. All right. I think in my head, I subtracted 6 instead of adding 6. So right here. Right here. This was supposed to be 37. All right. And this is also supposed to be 37. And then this is 37. Not too terribly bad. Okay, now it's asking us to do question 4. 1, 2, 3, 4 is here. Find the area of the region bound up by these graphs. We got y equals x plus 20 and y equals x squared. Okay. So this is question, what section does this come from? This comes from section 4.4. Okay. So this is question 4. This comes from section 4.4, question 17. Find the area bound. Fine, that's fine. So we have y equals x plus 20, and then we have y equals x squared. So one is a line, one is a parabola. We need to see where these two graphs cross. So we need to set them equal to each other and solve. So then if we have x squared equals x plus 20, set it to 0, minus x minus 20 equals 0. Maybe we can factor it into some form like this. So x and x, plus and minus, 5 and 4, so negative 5 and a positive 4. And we get x equals negative 4 and a positive 5. So when x is negative 4 and when the x is 5, the graphs are going to cross. Let me see. Okay. So between these, we need to figure out which of these graphs is on top, right? So for instance, when x is 0, because 0 is between negative 4 and 5, the first graph is 20 and the second graph is 0. So it looks like the first graph is on top of the second graph between negative 4 and 5, right? So I think we got to say the top graph minus the bottom graph, right? Then we're gonna take the integral as x goes from negative 4 to 5. Top one should be x plus 20 minus the bottom one should be x squared, and we're gonna say dx. Okay. So first one looks like it's what? Negative x cubed over 3. The integral of x should be x squared over 2. The integral of 20 should be 20x. You want to evaluate this as x goes from -4 to 5. So then when x is 5, 125 over 3 plus 25 over 2 plus 100. We get that answer. We're going to say minus. So that's going to be a positive 1664. Positive 8 minus 80. We just need to crunch this number. The error, type an integer or a simplified fraction. And you know what? Since this is gonna be the last one. I think I'm just gonna put the original in my calculator. This one. Okay. All right, so I'm gonna go to my y equals. Now we could crunch that number, that's fine. We can confirm it. We have x plus 20 minus x squared. Okay. If I go to math, we want to take the integral, so number 9. We want to call in that function we just put in. We want to integrate with respect to x as x goes from -4 to 5, -4 to 5. Okay. Let's hit math as a fraction. Okay. Looks like we're getting 243 over 2. I'm just going to go with it for the sake of time. 243 over 2. All right. So I'm going to shrink this down just so I can get it on one line. Shrink it down, move this over, and then expand it back. Are there any burning questions before we go our separate ways? I'm going to suppress this. Let me share. Get it to the box. Into the right folder. Spring. Traditional calculus notes updated daily. This should be 4.5. Okay. So when this bar finishes loading, you'll receive a copy of anything that you saw me writing. Let me see as far as announcements. So we only have one more section of new content, right? The last section we're going to work on Wednesday. This is the last section of new material. It's going to be integration techniques, integration by parts. It's fun. I enjoy that one. It can be a little bit challenging, but it's fun. And then so next week we'll, I think you'll have access to exam 2. So maybe one day I'll review, and then I might be kind of light another day. I'll probably do something like that. And then after next week, we'll be using the remainder of our time to review for the final. More than likely, we'll be reviewing 1 chapter a day. I think we have about 4 sessions after that. I think that's the rhythm. I had to check the schedule. Again, there was an excellent question at the start of class. The student was like, when's the last time that we can submit assignments? So the hard deadline for all assignments is that Friday, May 10th at 11:59 p.m. because shortly thereafter, we have to calculate final grades, right? So you can submit anything late, unlimited attempts. The system is going to take your highest score. There's a 5% late penalty, but that Friday, May 10th at 11:59 p.m., that's a hard deadline, right? Because I had to calculate final grades after that. Okay, so if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your evening, gentlemen, and we'll meet back on Wednesday, same time, same place. Take care. Peace.